So we've seen that some of Earth's radioisotopes are produced by cosmic rays, but where do the rest come from? Well, they're made by stars. In fact, most of the atoms on Earth, both stable and unstable, are made by stars. So how do stars make atoms, and how did some of those atoms end up here? Well, to provide explanations, we need to merge the study of nuclear physics with astrophysics, which is the physics of stars. The two often go together. Back in the 1920s, it was discovered that most galaxies are getting further and further away from each other. So if everything's getting further apart, then if you go back, everything was closer together. After studying the light from the farthest reaches of the universe, and by making calculations based on our knowledge of atoms, scientists suggested that about 13 billion years ago, everything was contained in a very small space, which suddenly started expanding. They called this event the Big Bang. Though there's still a lot that we don't know, the best mathematical models of the universe that we have suggest that only hydrogen and helium atoms were produced in the Big Bang, and maybe tiny amounts of lithium and beryllium. These atoms that were formed eventually coalesced together under gravity to form stars. So, where did the rest of the elements come from? Well, stars made them. Stars produce new nuclei in a process called nuclear fusion, where two smaller nuclei under intense heat and pressure join together, that is, they fuse together to form larger nuclei. In a typical star, including our Sun, most of the energy being produced comes from the fusion of hydrogen nuclei into helium nuclei. In one process, two hydrogen nuclei, that is, protons, collide and fuse together. The protons have to be moving at a high enough speed, of course, to overcome the force of repulsion by the positive charge that they both carry. Immediately after the collision, one of the protons turns into a neutron, resulting in the production of a positron and a neutrino. The two protons have fused together into a single hydrogen-2 nucleus. A hydrogen-2 nucleus created like this can then collide with another proton to form helium-3. A gamma ray is emitted in this step. Finally, two helium-3 nuclei created in step 2 can collide, and a helium-4 nucleus and two protons are produced, which then fly apart at huge speeds. So in stars, hydrogen nuclei end up fusing together to form helium nuclei, and a huge amount of energy is also released. As I said, nuclear fusion is the process by which smaller nuclei fuse together to form larger nuclei. In similar kinds of collisions, small amounts of other larger nuclei, like carbon and oxygen nuclei, are also formed. The outwards pressure of all the fusion reactions counteracts the inwards pressure of gravity, and so stars typically remain the same size for billions of years. However, the largest nuclei that normally get produced in stars are iron nuclei. There's usually just not enough heat and pressure inside stars to force more protons onto an iron nucleus. So how are larger nuclei formed? Well, when really large stars, much larger than our Sun, start running out of smaller nuclei to fuse together, the outwards pressure of fusion reduces and they collapse in on themselves. This triggers a gigantic explosion called a supernova explosion. Incredible amounts of light and heat are produced, but importantly to our topic today, atoms that are heavier than iron atoms are produced. Vast quantities of all these new atoms, plus the ones that were already there, are flung out into space and form huge clouds of gas and dust. Eventually, these huge clouds of gas and dust, rich in all of the different elements, collapse in on themselves under the influence of gravity, and new stars form. In the process, planets like our own also form. So that's basically a 4-minute summary of billions of years of the Earth's history. I obviously haven't gone into much detail. However, it's fascinating to think that we are made in large part of atoms, like for example carbon and oxygen atoms, that were made by stars billions of years ago. You and I are made in large part of stardust. Thanks for watching this short excerpt from Shedding Light on Nuclear Radiation Episode 7, Natural Radioisotope Production. To view the whole episode and the whole series, visit the LEM website by clicking on the link in the description below. The series covers all the essentials of nuclear radiation. In this episode, we look at how radioisotopes are produced in natural processes like nuclear fusion, decay, and what's called cosmogenesis, which is the formation of new nuclei when cosmic rays smash into existing nuclei. The video comes with an outstanding student activity sheet, which you can download for free from the LEM website. Don't forget to like and subscribe. See you next time.